Hello and welcome to our biotechnology documentary on artificial blood, presented by Rohit and Aneek. The heading of our article is Artificial Blood Developed for Patients of Any Blood Type. It was written on the 29th of September 2019 on the Asahi Shimbun, a Japanese media company. Synthetic blood was developed by Japanese researchers under claim that it can be used for any of the blood groups and types.
Blood is a highway of our body. It moves the vital ingredients our cells need from different parts of the body to others. The circulatory system through which blood flows has connections to the respiratory and digestive systems. The circulatory system is responsible for delivering oxygen and removing carbon dioxide through the lungs. The system also brings nutrients from the intestines to the cells and transports the waste to be removed. Blood can also control temperature. Blood vessels have the ability to contract to keep us warm and dilate to release heat from the body. Blood has the ability to fight off infections. It contains white blood cells, antibodies, complement proteins, and interferon, which fight infections and germs. Blood transfusions are required when the body loses blood or loses the ability to make blood. You can lose blood through surgery or an injury. Some diseases that result in the need for blood are anemia, sickle cell disease, hemophilia, and cancer.
Producing synthetic blood ties together with the genetics unit as it closely relates to blood inheritance. Obviously, artificial blood is artificial, meaning that there are no parents for the blood type to be inherited from. However, synthetic blood acts as a perfect substitute for the real deal. Artificial blood can be produced in various methods, the most common being hemoglobin based. This is made by first accumulating E. coli bacteria. It takes approximately 3 days for the hemoglobin protein to be harvested. First, a fermentation process is conducted, and a sample of the strain of E. coli is transferred to a test tube along with nutrients to help it multiply. After passing through the seed tank filled with warm water, food, and amino acids, the contents are transferred to a fermentation tank. Here, ammonia and water is mixed, and hemoglobin is produced. Once it has been purified through a process of isolation, the product may be given to a patient.
The discovery of artificial blood will save lives because it can be stored for longer periods of time than normal blood. According to the Japanese article, their artificial blood can last up to a year. This means that remote locations will have a more ready supply of blood, which could be the difference between life and death. At the moment, most remote locations don't have the blood they need and would have to either have a transfusion when an accident occurs or take the patient to another location to receive blood. This wait decreases the likelihood of survival. Another way artificial blood will save lives is its ability to be used by any person. Normally, the blood type of a patient has to be known before a blood transfusion can occur. This is because there are rules for which type of blood can be donated to certain people. As can be seen in the diagram, blood type O can give to O, A, B, and AB blood types. Blood type A can give to A and AB. B can give to B and AB, while AB can only give to AB. Looking at it from the other side, O can only receive from O. A can receive from A or O. B can receive from O or B, while AB can receive from any blood type. This means that O is the rarest blood as it only has one source, whilst AB has 4 different sources. This occurs because of antibodies in the blood. Antibodies respond to anything new in your immune system. They work to fight off bacteria and viruses. However, some bloods have antibodies that will fight blood cells that are different to themselves. This means that if type B blood is given to a type A blooded person, anti-B antibodies would be released from the A blood and kill the B blood that is donated. This is because the B blood is different to the A blood, so the antibodies seek the blood cells that do not belong and destroy them. This can be catastrophic as large amounts of the wrong blood through transfusion can cause kidney failure and ultimately death. Artificial blood, though, doesn't provide this problem because they don't have these antibodies that will destroy blood cells. This means it can be given to any person. This is not only useful because it means blood doesn't have to be sorted, it can also save lives because it means transfusions can occur in ambulances. At the moment, the blood type has to be known first, which can only be done in the hospital. But with artificial blood types no longer become relevant. At the moment, the amount of blood being donated is just enough to provide the blood needed. Problems could occur in the future if enough blood isn't donated regularly. Artificial blood will mean less real blood is required, reducing the strain. Artificial blood will obviously never be as good as natural blood. This is why blood donating will most likely still occur. One reason artificial blood isn't as good is it cannot fight infections. As mentioned earlier, actual blood has a variety of antibodies that keep the body safe from germs. However, in the future, new developments may occur where vaccinations are added to artificial blood to make it more useful. In reality, artificial blood mainly just provides the function of oxygen carrying. Artificial blood is also thought to have side effects such as blood flow being affected because of nitric acid being bonded. The blood can also result in bilirubin, amylase, and lipase levels rising. Another problem with artificial blood is its cost. While donor blood costs a hospital $6 per gram, artificial blood could cost as much as $1,000 per gram using the E. coli approach. This may mean that artificial blood will only be used in emergencies. An interesting issue, or lack of it, concerns Jehovah's Witnesses. Due to their religious beliefs, they do not accept any form of blood from other beings. They cite the command, "You must not eat the blood of any sort of flesh," from Leviticus 17:14. These messages in the Bible compel them from taking the blood of others. They believe that blood is sacred as it represents life. However, any blood supplement that does not include any major components of blood can be taken. This means that artificial blood made from non-blood bacteria E. coli would be allowed. In an article written by Jehovah's Witnesses, they said that the use of artificial blood would be left up to the religious conscience of each individual witness.
The following clip from TED describes a history of blood transfusions and how it was used in significant events such as World War I.
Up to this point, all transfusions had occurred in real time, directly between two individuals. That's because blood begins to clot almost immediately after coming into contact with air, a defense mechanism to prevent excessive blood loss after injury. In 1914, researchers discovered that the chemical sodium citrate stopped blood coagulating by removing the calcium necessary for clot formation. Citrated blood could be stored for later use, the first step in making large-scale blood transfusions possible. In 1916, a pair of American scientists found an even more effective anticoagulant called heparin, which works by deactivating enzymes that enable clotting. We still use heparin today. At the same time, American and British researchers developed portable machines that could transport donor blood onto the battlefields of World War I. Combined with the newly discovered heparin, medics safely stored and preserved liters of blood, wheeling it directly onto the battlefield to transfuse wounded soldiers. After the war, this crude portable box would become the inspiration for the modern-day blood bank, a fixture of hospitals around the world.
Many people around the world regularly need blood transfusions to save their lives. Currently, total blood donations are equivalent to the amount being needed, with 43,000 units of blood being donated daily and more than 38,000 units being requested. This seems pretty straightforward. However, there are many factors that impact donating and receiving blood. For starters, red blood cells can only be stored for 42 days before it becomes unusable, whereas artificial blood can be stored for a year and potentially longer. This means that people with rare or uncommon blood types such as B positive, A negative, or AB negative will have no problem accessing blood, as artificial blood can be produced for any blood type. According to the World Health Organization, up to 65% of blood transfusions are given to children under 5 years old in low-income countries, whereas in high-income countries, the common age group is over 60 years old. The rate of blood donation in low-income countries such as Ethiopia is 4.6 donations per 1,000 population, and as a result, blood banks in these countries are running out of blood. Mass production of artificial blood would mean that families of the needy would no longer need to donate emergency blood to save the lives of their loved ones. Three questions I still have about this topic are: will the price of synthetic blood drop over time? When will artificial blood appear on the market? And will blood substitutes be accepted worldwide? Thank you for listening.